My name is Higgs and this is my friend, Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Biostimulant Effects of an Aqueous Extract of Duckweed, or Lemna minor L on Physiological and Biochemical Traits in the Olive Tree. Biostimulants are various formulations of certain organic materials and microorganisms. Biostimulants aim to stimulate nutrition and crops' growth, increase their tolerance to environmental stress, and improve the efficiency in the use of natural resources of agroecosystems. In addition, biostimulants are gaining attention for the possibility of reducing chemical inputs as fertilizers.
Biostimulants are successfully utilized in both cereal and horticultural crops, as they are materials capable of promoting plant growth without being fertilizers, soil conditioners or pesticides. Currently, biostimulants are seen as an interesting and innovative technology to increase the ability of crops to cope with some adverse environmental conditions.
That is so intriguing, Boson. Biostimulants can strongly influence crops' ability to acquire nutrients, making their uptake and use more efficient. Such an effect, consequently, increases crop productivity and quality.
The researchers evaluated the potential of different concentrations of an aqueous extract obtained from duckweed to stimulate olive plants. Various plant growth parameters such as leaf net photosynthesis, leaf transpiration rate, stomatal conductance, substomatal CO2 concentration and chlorophyll content were investigated. We can draw some important conclusions. This study showed that the duckweed extract generally increased nitrogen, potassium, magnesium, calcium, iron and zinc contents in treated olive trees. Differently, sodium, manganese and copper contents were unaffected by the plant extract.
That is a very positive observation, Boson. All the treatments significantly elevated nitrogen and potassium. This effect could be related to the higher photosynthetic activity, chlorophyll content, and biomass shown by olive samples treated with the extract. Generally, the impact of biostimulants on nitrogen content is attributed to their ability to stimulate the enzymes of the nitrogen metabolism and upregulate the root nitrate transporters, as shown in recent studies carried out in maize and soybean. Potassium acquisition can stimulate the photosynthetic activity. All the treatments increased the magnesium content, exerting a beneficial effect on this nutrient acquisition.
The highest dosages of the duckweed extract affected iron content. Plant productivity depends on this nutrient for its involvement in photosynthesis. Zinc was slightly increased by the highest dosage. Increases in the content of this element could be of relevance as zinc is involved in chlorophyll biosynthesis and chloroplast development.
In summary, this study revealed for the first time that duckweed could be seen as a promising species to obtain extracts with biostimulant properties in olive trees. Finally, this research highlighted that biostimulants could be found from resources readily available in nature. That was an interesting paper to review. Hope you liked it, Boson.